Have you ever stared at a math test, read a question about ringing bells or marching armies, and felt your mind go completely blank? You know how to multiply and divide, but the prompt doesn't make it clear which formula you actually need. Many students rely on keyword guessing to survive these problems. Test makers use deceptive prompts like maximum or minimum specifically to lead you toward a formula that doesn't fit the actual logic of the scenario. Over the next few minutes, we are going to replace keyword guessing with a foolproof mental logic test that bypasses those word traps entirely. Grab a pen and some paper. If you understand the basics of prime factorization, you already have every skill required to follow this method. Mastering this single mental framework shifts your approach from panicked guessing to mathematical certainty. We call this framework the size trick, and it serves as a definitive replacement for keyword guessing in Class 10 real numbers problems. First rule: if the real-world answer must be physically bigger than the provided numbers, calculate the least common multiple, or LCM. The inverse follows. If the answer must be physically smaller than your starting numbers, calculate the highest common factor, or HCF. Let's apply this to a practical scenario. Imagine 3 bells ringing at 12, 15, and 18-minute intervals. If they just rang together, when is the next time they will all toll at once? To run the logic test, try a guess that is obviously too small, like 2 minutes. Check that guess against the reality of the bells. The bells cannot ring together in 2 minutes because the fastest bell in the group takes 12 minutes just to ring once. The true answer must be a much larger number than our inputs. Because the real-world answer is definitively larger than the 12, 15, and 18 we started with, you have proven that you must calculate the LCM. Now, consider a different scenario. You have 1,000 Army members marching behind 56 band members, and you need to organize them into the maximum number of columns. You must actively ignore that word maximum. Test makers use it to trick you into choosing HCF. Apply the logic test by guessing an impossibly large answer. Imagine trying to organize these soldiers into 10,000 separate columns. A group of only 1,000 people cannot fill 10,000 lines. The number of columns must be smaller than the population of the army. Anchoring your strategy in physical logic rather than deceptive vocabulary points you directly to the HCF and prevents a catastrophic error on the exam. We have our theory, now we execute the math. We'll return to the bells problem and calculate the LCM of 12, 15, and 18. Let's factor. 12 is 2 squared times 3. 15 is 3 times 5. 18 is 2 times 3 squared. For the LCM, extract the highest power of every distinct prime, 2 squared, 3 squared, and 5. Multiply them for a total of 180. Prime factorization turns our physical logic into hard, indisputable data. Warning tone. Stopping at the raw mathematical output of 180 is a critical failure point that will cost you marks. You must recontextualize that data into the original units of the problem. In this case, our output represents 180 minutes. To find the actual time, we convert those minutes into 3 hours. If the original start time was 8 a.m., our bells will next toll together at 11 a.m. Reattaching the mathematical output to the physical reality of the problem is the definitive final step to a flawless answer. You now have the ability to ignore deceptive vocabulary, use pure logic to select your formula, and calculate the correct result every time. Success in real numbers depends on translating the written scenario into the correct mathematical equation before you ever pick up a pencil. To lock this in, open your textbook right now and locate 3 word problems you haven't solved yet. Don't do the math yet. Practice only the mental logic test to decide between HCF and LCM. Mastering this upfront decision-making process turns a confusing, terrifying word problem into a predictable, easy-to-follow set of steps.